Okay, so in our yesterday's class, we studied union. Okay, operation on sets. Under the first operation of sets, the first operation was intersection of two sets. And intersection of two sets means the common elements in both the sets. That is intersection of two sets. Then we saw disjoint sets. So when are two sets said to be disjoint? When none of the elements are common in them. Okay, that was the second thing that we saw, disjoint sets. Then the third thing is union of two sets. So union means all together. So writing the elements all together, that is a union of two sets. And then the last topic before we finish our lecture, we saw was that was a number of elements in a set. So how many elements are there in a set? That is called as number of elements in the set. So it is the number of elements is denoted by n of a. So n of a will give you the number of elements in that set. Now, this what we saw, that was just number of element in one set. The new concept that you will study today is number of elements in union and number of elements in the intersection. Okay, so in the union and in the intersection, how will you find out the number of elements in that set? Now for that, we have a different formula. So suppose you consider two sets, say set A and set B. Okay, let us consider the set A and set B. This same example we are taking. Okay, this is set A, this is set B. What is n of A? Can you tell me?
5.
And what is n of B?
6.
6. So n of A is 5, n of B is 6. That same thing we are considering here. So n of A plus n of B, which is 5 plus 6, that is 11. Is this much clear what I did? Now this what
Yes,
we are
sir.
doing is little bit derivation. So slowly try to understand. Okay, I'll go slow, but see that you understand all the steps. Okay, so n of A plus n of B is 5 plus 6, which is 11. Now, if you take A union B, okay, I'll go back to the previous slide. So can you tell me what is A union B?
It will be.
Tell me the elements.
Yeah, it will be all the elements.
Yeah, tell me. What is all?
C equals 3, 6, 9, 12, 15, 6, 12, 18, 24, 30.
You will not repeat. You will not repeat it. 6 already wrote.
Oh,
no?
yeah,
So you want
yes.
me to write it again? No.
Yeah.
So after 12?
15. 15, then 18, 24, 30, 36.
So this is A union B. Okay, that same thing I'm writing here. Okay, this is the same thing, A union B. Okay, now you count how many elements in this.
Nine.
So n of A union B is equal to 9. Correct? Okay. Now let me come back to the previous slide. Now, can you tell me what is A intersection B?
The first set, right, sir? The first A and B set.
Yeah, this one only, in this only.
Sure, in the middle there would be 6 and 12.
6 and 12. So A intersection B is 6 and 12. So A intersection B is 6 and 12. How many elements in this?
2.
2. So N of A intersection B is equal to 2. Now, if you see one thing that okay, this is A and this is B, and this is A intersection B. Okay, now if you see that in N of A, how many elements were there?
5.
5 elements were there. And in N of B, there were 6 elements. Okay, and in the intersection, there are just 2 elements. So if you note one thing, that in the intersection, in N of A, you counted 6 and 12. In N of B also, you counted 6 and 12. So that means 6 and 12 is counted 2 times. Correct? It's counted 2 times. So what you do is N of A plus N of B. From there, you subtract N of A intersection B. So N of A was 5, N of B was 6, and N of A intersection B is 2. So 5 plus 6 minus 2, that will be 9. And this 9 is same as the union. So N of A union B will be 9. So from equation 1, 2, and 3, you can say that N of A union B will be N of A plus N of B minus N of A intersection B. Have you understood this formula? To find out N of union, number of elements in the union.
Yes, sir.
Okay. So remember this formula. N of A union B will be N of A plus N of B minus N of A intersection B. Okay. Also remember this. You're doing subtraction, minus A intersection B, because this element in the intersection is counted 2 times. So it is counted when you count elements in A. Again, it is counted when you're counting elements in B. So this element in the intersection is counted twice. So that is why we subtract N of A intersection B, so that it is counted only once when you're finding out number of elements in the union. So this is a very important formula. This formula is also called as addition law. Okay, this formula is also called as addition law of sets. Okay, this formula is also called as addition law of sets. So this formula says n of A union B will be equal to n of A plus n of B minus n of A intersection B. Clear? Okay, now we'll see this question. In this question, they have said verify the rule. Means the formula which we just studied. N of A union B is equal to n of A plus n of B minus n of A intersection B. This formula, what you have studied, you have to verify. Okay, so let's verify. Solution. N of A. Can you tell me what is n of A?
5.
N of B?
6.
A union B? So you count all.
11.
Everything. And A intersection B?
9.
A intersection B. Intersection, how many elements are there?
9, sir. 9.
Intersection. This is the intersection. How many elements are there?
In intersection, we count the common numbers only once, right?
Oh.
So it would be 9, sir.
Oh, 9. How many elements are there in this portion?
2, sir.
How many?
2.
2. So won't number of elements in the intersection be 2?
Yes.
And union? Union means count all together. Okay, count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. So altogether, how many elements?
9.
9. So A union B will be 9. Now we have to verify this. So substitute. LHS. So we have LHS, RHS. So in LHS, we have A union B. So N of A union B is equal to 9. RHS. In the RHS, what you have? N of A plus N of B minus N of A intersection B. Substitute the values. N of A is 5 plus N of B is 6 minus N of A intersection B is 2. 5 plus 6 is 11 and 11 minus 2 is how much? 9. 9. So LHS is equal to RHS. So that is 9 is equal to 9. Therefore, the rule is verified. Is this clear?
Yes, sir.
Okay. Okay, so you remember this. So you remember this. This is the formula. N of A union B is N of A plus N of B minus N of A intersection B. This formula itself is just rearranged. So this minus A intersection B, you take it on the other side. So when you take this minus A intersection B on the other side, what will happen?
Plus.
Plus.
Addition plus.
Plus. Plus. So n of A intersection, you will get it like this. N of A union B plus n of A intersection B is equal to n of A plus n of B. Correct? And this is just rearranged and you get this one. Have you understood?
No, sir. Can you explain?
Did you understand this? This how I got?
No, sir.
This. No? Okay, so the formula which you just studied was n of A union B is equal to n of A plus n of B minus n of A intersection B. Correct?
Yes, sir.
Now just take this minus n of A intersection B on the other side. So this n of A union B as it is minus n of A intersection B came on the other side, what will become? Plus. So plus n of A intersection B is equal to this as it is, n of A plus n of B. This much clear?
Yes, sir.
Now, what we'll do is it is just a rearranging. You're not doing anything, you're just rearranging. So this, I will just write it this side, and this, I'll just write it this way. It is just rearranging. So n of A plus n of B equal to n of A union B plus n of A intersection B. So I just written this here and this here, rearranging. Now, is it clear? Did you understand? You're not shifting anything. You're only rearranging. Clear? So this was the first formula. This one was the first formula. And this one, the second formula. Both are the same, only written in a different manner. Now, is it clear? Yes or no?
I understand, sir.
Okay. So this it is. So this was the first one. This was the second one. Clear? No doubts? Okay.
Yes, sir.
Now we'll come to the word problem. Now this is if you know the formula, this word problem will be easy. So we'll try to understand this in terms of the Venn diagram. In a class of 70 students, 45 students like to play cricket and 52 students like to play Kho-Kho. Okay, so there are 70. From this 70, 45 likes to play cricket. And from this 70, 52 likes to play Kho-Kho. Okay, so 45 and 52, 70. All the students like to play at least one of the two games. Okay, now they're saying from this 72, from this 70, all of them like to play at least one of the two games. Well, what do you mean by at least one of the two?
either like to play cricket or Coco.
Or
Or
both.
they both.
Or both.
Or both.
Or both. So at least one means that student likes to play cricket, or that child likes to play Coco, or both. That is the meaning of at least one. You have to find how many students like to play cricket or Coco. Okay, you have to find out how many students like to play cricket or Coco. Did you understand the question? Yes?
Yes, sir.
Okay, so we'll start with the solution. So there are two methods to solve this sum, and I'll show you both the methods. Let's see method 1. So total number of students is 70. Let A be the set of students who likes to play cricket. Okay, so remember this. What is A? A is set of students who likes to play cricket. Then what will be B? Set of students who likes to play Coco. Correct. And how will this look like? All the students like to play at least one of the two games. So what would be, see, if A is a student who plays cricket, B is the number of students who play Coco, then what would be A? All the students in the class would be A union B. Yes. And how many students are there in the class?
70.
70. So N of A union B will be 70. Up to here, is it clear? So N of A union B is 70. Now, number of students who like to play cricket and Coco. Okay, cricket and Coco. What does that mean? So suppose if this is A and if this is B, this is who plays cricket, this is who plays Coco. Then what will this mean? What will this be?
People who like to play both.
Who like to play both. Who likes to play cricket and Coco. So number of students who likes to play both cricket and Coco is N of A intersection B. This you have to find out. Now, can you tell me which formula to use to find out this?
The first one, sir?
You can use the second one also. Because both are the same. So N of A is 45, N of B is 52, that is given in the question. So we know this formula, N of A union B, N of A plus N of B minus N of A intersection B. Correct? Now what you do is you just substitute the values. So what is N of A union B?
$70.
N of A?
45.
Plus N of B?
52.
And N of A intersection B? You have to find out. You have to find it out. So write it as it is. You have to find out this. Is it fine up to here? Yes? Up to here clear? Yes or no? Okay. So 70 is equal to 45 plus 52. How much is 45 plus 52?
97.
97 minus n of A intersection B. Take this minus A intersection B on the other side and take this plus 70 on the other side. So what will happen? N of A intersection B is equal to 97. What should I write next?
Minus 70.
Minus 70. And how much is 97 minus 70?
27.
27. So N of A intersection B is equal to 27. What does this 27 represent?
The number of students who like to play both cricket and Kho-Kho.
Correct. So 27 students likes to play both cricket and Kho-Kho. Clear? Okay, go through the sum. Go through this entire sum. If you have any doubts, you can ask me. Let me know once you are done.
No, sir, no doubts.
Okay, so you can write this later. Now, the same sum, we have another method for it. So given information can be shown by Venn diagram as follows. So if A intersection B is X, that is this, is X, then this portion. Okay, try to understand this way. We are taking this part to be X. Okay, so this portion is X. Better, I'll use some different colors. This portion marked in green is X. Now, this entire circle is A. Okay, this entire circle is A and this entire circle is B. Number of elements in A is 45. That means this entire thing is 45. Okay, now if this entire thing purple, if you see the purple shaded, that is 45. So if that is 45, then can you tell me what will be the red shaded portion? Only the red, that is only this much part.
People who like to play cricket.
How that will be in terms of equations? So if this is X and the purple is 45. The purple is 45. That means entire circle A is 45. So how much will be the shaded portion? What you said is correct. The red portion is only those people who likes to play only cricket. This is correct. But in how will you write it in terms of Mathematically, how you'll write it? Okay, think of it this way. If this from here to here, if this length is 10, okay, if this length is 10, from A to B, length is 10. And here middle you have point C, and this is 2. From A to C it is 2, and from A to B it is 10. How much will be this length?
8.
8. What you are doing to get 8?
I am subtracting 2 from 10.
You're doing 10 minus 2 to get 8. Correct? Think exactly same way, think here now. Entire circle is 45. And this green portion is X. How much will be the red portion?
$35.
This is X. This is X here. Look at this circle here now. Suppose this entire circle is 10. Entire circle is 10. And this portion is 5. This portion is 5. Then how much would be this from here to here? Entire circle is 10. And this is 5. So how much would be this?
So the other part of the circle would be 5.
5. What did you do to get 5? You did 10 minus 5.
Yes.
Same thing do here. This middle is X and entire circle is 45. So what will be the red part? 45.
25.
You have a variable here, X here. See, this is 10 minus 5. So what will this be? This minus this. So what will this be?
Then 45 minus X.
Yes, correct. 45 minus. Did you understand now how 45 minus
Yes,
X?
sir. Yes, sir.
What about B? This B is 52. So how much will be this portion?
52 minus X.
52 minus X. Good. So this is X, A is 45 minus X, B is 52 minus X. Now, I hope this is clear how I got this and this. Okay. Now we'll use the formula N of A union B is equal to N of A plus N of B minus N of A intersection B. Now, A union B is 70. We know that. Substitute the value here. 70 is equal to. What is A?
45.
Look at this, the new thing that you got.
45 minus X.
Oh, no, sorry. Correct. You said 45. A is 45. B is 52. And N of A intersection B is X. We considered it to be X. This is X. Same thing we are doing. This is 70. 45 plus 52 is 97 minus X. So same thing, you take minus 6 on the other side and take 70 on the other side. So you have 97 minus 70. This would be 27. So X is 27 here. Up to here, is it clear? It's exactly the same like the previous sum up to here.
Yes, sir.
Okay. Okay. So if they ask you, okay, that's it in this sum. Actually, this first method and second method is almost the same. Only it's just that in this method, we are showing it in the Venn diagram. And if they ask, find the number of students who like to play only cricket, how will you do that?
I would subtract 27 from 45.
Yes, correct. So number of students playing, number of students who likes to play only cricket. Only cricket. That would be 45 minus 27. How much is it? How much is 45 minus 27?
18.
18. Exactly same way you can do it for number of students who likes to play only Kho-Kho. Clear up to here?
Yes, sir.
Okay, practice set 1.4, first sum will do. So this says, if n of A is 15, n of A union B is 29, n of A intersection B is 7, find n of B. Can you do this one? And tell me the answer. Use the formula. N of A union B is equal to, can you tell me the formula? Do you remember by now?
N of A plus N of B minus N of A intersection B.
Substitute the values. A union B is 29 equal to N of A is 15 plus N of B is, you have to find out. So keep it as it is. Yes, there's a question mark here, so we have to find out this. Minus N of A intersection B is 7. Can you complete this? Unmute. Unmute and say.
I'm calculating, sir.
Okay, tell me stepwise. What to do step by step?
As A union B is 29, and as we normally take numbers of A and numbers of B and add them together, and we subtract it with the intersected number, then I think
first what you do is do this 15 minus 7, do that first. Write this n of B as it is, plus 15 minus 7. Understood this? What I did here? Yes or no? No? Do you understand this step? Unmute yourself and say.
no, so I don't think so.
Up to here, is it clear?
Yes, sir.
Okay. So you have here 29 equal to 15 plus n of B, which you have to find out, minus 7. Okay, clear? Now here you keep this n of B as it is, this side. 29 is equal
so
to...
I have a question.
Yeah.
Is the answer 21 B, n of B?
21, 1.
So I'll check in my textbook.
$21, it's correct. How you got 21? Tell me that also. Unmute.
Okay, so I first, when I found out the answer was 29, I added 7 to it, then it became 36, then I subtracted 15, then I got 21.
Correct. So this is what you did. You did 29 plus 7. You took minus 7 on the other side. So 15 plus n of B. And this gave you 36, correct? And then you subtracted 15. You took plus 15 on the other side, which became minus 15. And 36 minus 15 gave you 21. Is this what you did? Correct. Correct.
Yes, sir.
Then n of B is equal to 21. Okay. We'll do the second one of this exercise. So this says, in a hostel, okay, listen to the question carefully. In a hostel, there are 125 students in total. Out of this 125, 80 drink tea, 60 drink coffee, and 20 drink tea and coffee both. Find the number of students who do not drink tea or coffee. Is the question clear? What you have to find out? You have to find number of students who do not drink tea or coffee. Is it clear question? Yes or no? Okay, so we'll start with the solution. We'll say let A be the set of students who drinks tea. Let A be the set of students who drink tea. Then we'll say let B be the set of students who drinks coffee. Correct? Okay. So what will be N of A?
80.
N of A will be 80. N of B will be 60. What else is given in the question? What is 20?
20 as a number who drink tea and coffee both.
Both. So students who drinks both tea and coffee. Both tea and coffee. So this would be, what would this be? N of what?
Tea.
How would that look like in terms of set notation? Students who drink both tea and coffee.
A intersects B.
Yes, A intersection B. This is given how much? 20. Correct?
Yes, sir.
Okay, but what is asked? Find the number of students who do not drink tea or coffee. Okay. One more thing is given. What is this?
Students.
Total number of students. Okay, total number of students is given to you. Total number of students is given. That is 125. This is the total number of students. Okay. Now in this, what they have said, in this, from this 125, 80 drinks tea, 60 drinks coffee, and 20 drinks both. They've asked you how many do not drink tea or coffee. Okay, so first you find number of students who drink tea both. Number of students who drinks tea or coffee. First, we'll find out this. Okay. What does this mean? Students who drink tea or coffee, that would be N of A union B. And this formula we know, this is N of A plus N of B minus N of A intersection B. Substitute the values. This is 80, this is 60, and A intersection B is 20. So how much is this? 80 plus 60?
120.
120?
80 plus 60, 140.
Total you're saying 120?
Yes, sir.
Okay. So N of A union B is 120. Now, what does this 120 mean? What does this represent, 120?
People who drink tea or coffee.
Tea or coffee. So if you look at the Venn diagram, look at it in terms of the Venn diagram. This is A, this is B. A is 80, B is 60, this is 20. Total number of students in this hostel is 125. And A union B, that is this entire thing, is 120. Looking at this diagram, can you tell me now how many students don't drink both?
5.
5, yes, 5. So, students who do not drink both, do not drink both tea and coffee is 125, that is total number of students, minus 120, that is number of students who drink tea or coffee, that is 5. So there are in total 5 students in this hostel who do not drink both of it. Is this clear? Did you understand the sum?
Yes.
Okay, I'll just zoom out. Can you see the sum from top to bottom?
Yes, sir.
You can zoom it also. Can you zoom?
Yes, sir.
Okay, now I want you to go through the sum right from the start to end. Go through it.
Yes, sir.
Okay, so we will stop here. And in this exercise, we have 3 more sums remaining. So this will finish on Tuesday. Okay. Okay. So I'll stop here. And next week on Friday. So my class will be on Tuesday. Okay, so next week, my class will be same days I'll take: Tuesday, Thursday, Friday. Okay, on Friday, I will take a test. Okay, so you practice. So we'll stop here. See you on Tuesday.
Bye, sir.
Bye. I will upload, so see that you finish writing it also.
Yes, sir.
Okay.